Welcome back, class 11th. In the previous lecture, we have discussed about the problems on rain and man, and the second crossing the river. And I don't think you are doing well because no one is putting any questions. So let's see how much time you will take to solve the question, and you will inform me that I'm facing problem or not. Not even you have given about any question about the cross or dot product. So again, I'm going to the next topic, that is projectile motion. Everyone has thrown the object. Suppose I'm throwing this object. So when I'll throw it, it will go first high and then it will go down. Why? The earth is continuously pulling towards the earth. Due to the gravitational force, it is coming down. But in starting, my force was active more than the gravitational force, so it was going up. Then the velocity becomes zero, the kinetic energy becomes zero, converted to potential energy. Now the gravitational force comes to in existence, or you can say active. So this changes to kinetic energy, and but due to the gravitational force. First by my force, then gravitational force. So here this object is what? Projectile. We used to say the India has launched or projected a new satellite. So that is what projectile. Whatever we are throwing, this is what? Projectile. And the path at which this projectile has gone, suppose this is the path. So the path at which this projectile has gone, this path is known as trajectory. Remember, projectile and trajectory. This is the path, suppose, and here is the object. Object, say any football. I'm not good in drawing. So this ball is projectile, and the path is what? Trajectory. Same thing we are going to discuss in this topic. Suppose a girl is throwing any object and it follows this path. So here the path is what? Trajectory, and the football is what? Or any object you can see, that is what? Projectile. So which shape of this projectile is? Circle, triangle, line, oval. What is that? Let's calculate which path it is called. Suppose a projectile is thrown in this direction. This is the ground. From the ground it was thrown in this direction initially, suppose with the angle theta. Let us consider the angle is theta, and suppose it is arriving here. So what you will observe, this section, this velocity, means this projectile moving in this direction will have the two component of velocity. Why? Not only the object is going ahead, but also the object is going up. Means the projectile is moving forward and in upward direction both. Means definitely the velocity will be having two components. One component is taking in forward direction, second in the upward direction. So I am distributing that with the vector law. One is this, and second one is this. So horizontal one will be known as Vx, and the vertical one will be known as Vy. The angle will be different here. At every point the angle will change. See, you can see here the angle, due to the change in the angle, it becomes horizontal here. At this time the velocity has this component only, what? This Vx. Vy has gone. Now further, suppose the object comes to here, or you can say projectile comes to here, then at that time it has the velocity component in this at different angle, and when it will come to here, same. So we have to calculate what type of this trajectory is. We want to name the trajectory. Suppose the equation comes y is equal to mx plus c. So you can say it is the straight line. Suppose it comes to different equation, means regarding the equation we can say which shape of the trajectory is. So again, at this point, if this angle is theta, same way here also, this will be what? Vx, and this will be what? Vy. So remember, the Vx component is taking the object forward, or you can say towards the horizontal side, and Vy component is taking the object in the upward direction. So here, taking this angle, we can say the Vx is equal to, if the initial velocity of the object is v, if the initial velocity with the velocity object is thrown, sorry, not initial velocity, it has symbol v, it is having the symbol u, initial velocity having u. So what you can say, Vx will be u cos theta. You can split it into its components. So horizontal component is called u cos theta, or you can remember it like that. The component which is along with the angle will be with cos theta, and Vy will be what? U, and this one is what? Sin theta. So this one will be sin theta. So using that, I am going to solve further. Let's clean it and make it at corner point. So here I have drawn that diagram into a smaller size. We are assuming that when we will throw in the object with velocity u, it will follow this trajectory. But we have to take some negligence, or you can say we have to consider some points as our convenience. First point that we have to consider that at every place the value of g is same. Second, we can consider that means we have to ignore the shape of the earth. Means this is for the horizontal one, but the shape of the earth is little bit curved, and the air resistance, because of the air resistance, they actually, when you will throw, so we are considering that it will go like through this trajectory, but actually it will go from here up to here only, but we are considering what? There is no air resistance. So considering these points, we have to follow forward the next steps. Let's calculate the time taken to move from this point to this. Let's name it point O, point A, point B. If suppose this is not the surface of Earth, so it will also have at this point some velocity in this direction. It will having its component in this direction and this direction. But I am considering that here is the surface of Earth, and here after striking the object comes to rest. So we are going to calculate what the time is taken. As the projectile moving through this path, and we are considering that the acceleration due to gravity is constant at everywhere. So this Vy, suppose u sin theta, is changing, and here it becomes 0, while ux, that is u cos theta, Vx, that is u cos theta, is not having any effect due to the gravity, acceleration due to gravity. Means the ux component, the x component, the horizontal component will be unaffected by the value of g, means acceleration due to gravity. So let's calculate the horizontal distance first. So horizontal distance, let x, distance or displacement is equal to velocity into time. So which velocity? Horizontal velocity, because we are not going to talk about the height, we are going to talk about the horizontal side, this way. So Vx, why Vx? We are talking about the horizontal only, into time. Let the time taken for this is small t. So what is Vx is u cos theta, put here u cos theta into t. Now our main motto to establish an equation, you seeing that, or means with that we have to say which shape it is. So let's calculate t from here. So t is equal to x upon u cos theta. Let the maximum position at A is the height h from the ground. Now this is the time to talk about the vertical axis, means Vy. So let's calculate the height, which is h is equal to ut minus half gt square. Minus because the object is going in upward direction. So h means maximum. So we are considering that let this is going y distance. We are talking about the y axis. So u will be what? U y into t minus half gt square. Fill the value. Y axis and x axis. So y means y axis, that is y h. So uy, what is uy? U sin theta. U sin theta into what is t? X upon u cos theta. X upon u cos theta minus half g. T means again x upon u cos theta whole square. On solving, see, u is cancelled, sin theta upon cos theta is what? Tan theta. I am writing directly y is equal to tan theta into x minus half g. I am separating something, minus g upon 2 u square cos square theta into x square. See here why I have separated the x square, because the equation means the equation which is linear in y and quadratic in x. See this equation, linear in y and quadratic in x. This type of equation gives information that the equation represents the parabola, means trajectory of the object. The trajectory of the projectile is what? Parabola. For example, if suppose this equation comes in this form, y is equal to x minus suppose 5, this y is equal to x minus 5. So at this time you can say it is resembling like y is equal to mx plus c. The c means negative, it is here. So with this equation we can say it's a straight line equation. Same way here, if any equation linear in y, quadratic in x, if it is, so that represents what? Parabola. Remember, parabola, and the path will say, trajectory will be said parabolic. Now the 3 points that we have to calculate from this graph, from this trajectory, that is very important for our numerical section. The 3 points are the flight time, means the time taken from here to here. Second, the maximum height from here to here, what maximum height that it can go. And the third, the maximum distance that it can cover. So let's start from the first, the flight time. So we are going to calculate the time taken by this projectile from point O to point B. We are not having the straight equation. So instead of that, let's calculate the first time from point O to point A. And the time taken from O to A will be same the time from A to B. Means after calculating the time from A to A, we will just double it. So let's calculate from A to A, O to A, because at this point when the object reaches at A, at that time the vertical component of velocity becomes 0, means we can say at point A Vy is equal to 0 while Vx is u cos theta. So let's use the first equation of motion, that is V is equal to u minus gt. Why? Because the object is moving against the gravity. So at this time when it goes up, so it will be what? Vy, uy and gt will be remaining same, because g is a constant everywhere, we are considered there. So Vy at this point will be 0, uy means you can say horizontal velocity at this time, that is u sine theta minus dt. So t will be equal to what? U sine theta upon g. So this is the time taken from O to A, the total time, or you can say the time of flight or flight time. So flight time is equal to 2 into small t, so 2 into u sine theta upon g, and the symbol for the flight time is capital T, that is 2u sine theta upon g. So remember this, because there are many questions which are based on this topic. The next topic is the maximum height. Let's see. Now let's calculate the height of projectile. For the height of projectile, we can use the third equation of motion, that is v square is equal to u square minus 2gh. So again, we are going to calculate the height, means the vertical component of the velocity, means here uy and uy and vy both. So what is the vertical velocity at this point? I want to inform you, this is the initial velocity and this is the final velocity. So the final velocity at this point, because we are going to calculate what? H, means we have to talk about only at this point from O to A. So what is final velocity? What is final velocity at A? This is Vy, and that is 0. So here it is 0. And again Uy at initial point or initial velocity, that is u sine theta. So u sine theta whole square minus 2gh. We have to calculate h. So let's put it here. So h is equal to u square sine square theta upon 2g. And what will be the maximum height? Means up to which height it will go? Maximum and maximum height. So maximum value of sine theta is 1. So you can say h maximum, possible maximum value, is u square upon 2g only. So here we have calculated the height of projectile. Now the next is range of projectile. Range of projectile means the distance covered from O to B. Listen carefully. From O to B, it is very clear that we are talking about only the horizontal component. Means we are not requiring the vertical component. Only about the horizontal component of velocity. Means we need only u cos theta. Second thing, now at this time we know the total time taken. This one we know, means distance is equal to velocity into time. We can calculate. Let's calculate using that. Range of projectile is represented with capital R. So R is equal to velocity into time. Displacement is what? Velocity into time. So velocity means Vx component into time taken from O to B is capital T. So what is Vx? U cos theta. U cos theta into capital T is cos, about 2u sine theta upon g. I have taken this from here. We have already proved it. So just put u square here and 2 sine theta into cos theta together upon g. If you are a mathematics student, so you are well aware of this, that 2 sine theta cos theta is sine 2 theta. If you are not knowing that, then you have to remember this. This is the identity, that 2 sine theta cos theta is sine 2 theta. So R is equal to u square sine 2 theta upon g. So this is the third equation of. Now let's talk about the range. In this animation again, see, the girl is throwing the object, one at very high, second at very low, and the third at some angle, but it goes very far. So what should be that angle? Means if you want to throw any object, so at what angle you should throw that to get the maximum distance. So for R maximum, say here, this should be 1. Remember this, sine 2 theta should be 1 for maximum value of sine, or sine 2 theta is equal to sine 90, sine cancel, so 2 theta is equal to 90 degree, or theta is equal to 45 degree. So at that time what you will get, the maximum range. If you throw any object at 30 degree, it will go high maximum, but it will go to closer to you. If you throw it at 60 degree, it will go a little farther, but again it will fall down at the same point where the 30 degree was. But if you throw at 45 degree, so it will go in between them and it will cover maximum distance. So at that time R max, you can say R maximum will be what? This will become 1 U square upon G. So there are many questions based on these 3 topics you have to solve, and I am waiting for your queries. Till then, thank you.